Okay, so I've done arithmetic sequences. They're a little bit boring, aren't they? But not too bad. Now let's get on to geometric sequences. Okay, geometric sequences. Perfect. So remember, geometric means that it's something that multiplies. So 1, 2, 4. That's a boring example on there, I'm sorry. Something that multiplies by the same thing every time. We call that thing that multiplies the ratio. So we're multiplying by 2, we're multiplying by 2, we're multiplying by 2. So multiplying by 2, so r is equal to 2 in this case here. Okay, so that's what we're talking about. I'll show you this in class, but basically the nth term of any geometric series will be a, so the first term of the sequence, times by the r, the ratio to the power n minus 1. And so that's the important formula here, I'll show it in class, to figure out any term in a geometric sequence. So let's just go straight to an example, not much to this. So find the 15th term of, let's do 16, 8, 4, 2, dot, 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 dot. Okay, find the 15th term of this. Alright, let's write all that information down. What's n equal to? We want the 15th term, so n will be 15. What's the first term? The first term is 16. And the ratio, what's the ratio? Well, what are we multiplying each term by? And in this, it's actually dividing by 2, isn't it? So, but we need to write down what it's multiplying by. Always write down what is it being multiplied by. In this case, it's being multiplied by half. Half, half, half. Multiply by a half. You can write it 0.5 or half or however you want to write it. Doesn't really matter. So that's our ratio. Let's use the formula. So we want the 15th term, so we want T15 equal to A, so 16 times, I'll just write my times up here, because otherwise people get confused. 16 times R is half, so we'll do half, to the power of n minus 1 was n was 15, so it'll be 14 up here. And that's just something you'll plug straight into your calculator. Now, I'll just show you something on the calculator. So, if you type in 16 times, and I'll just put in a bracket, let's say let's say we write it in as 0.5 to the power of 14. And enter. Look, it gives us a decimal answer. And the reason it gives us a decimal answer is because I put this half as a decimal. Let me do it again, and I'll enter in, instead of writing 0.5, I'll actually put it in the calculator as a half by putting in a fraction. And let's see what happens. What do you think will happen? Half, I'll leave it there, to the power of 14. Okay, and what it does is it gives us the answer as a fraction, and this is much better, much more preferable in maths. It's much nicer to get a fraction than some crappy old decimal up here. Okay, so the answer for this one is 1 over 1024. That's the answer. Okay, beautiful. Nice and simple. I'll do another example on a fresh page, I think, just in case. I just hate running out of space, as you've seen in previous videos and in other examples. If you invest $4,000, invest $4,000 at 3% compounded annually, find the value of your investment after 10 years. Okay. Okay, so what this is doing is that when you invest money into an account, it grows by 3% every year. Okay, so that's what this means. Every year, annually, compounded means it grows by 3% every year. So that'll just grow and grow and grow. And so let's just have a think about this. First, what's your initial value? Your initial money that you have in the bank is $4,000. What's the ratio? if something grows by 3% every year, how much will it grow by? And it's a bit hard to think about. If it's 3%, if something grows by 3%, then what it's actually going to be doing is be growing by, well, I don't want to confuse anyone, just let me write down here. So 3% means 3 over 100, which is 0.03, okay? And so if you write down 0.03, what that'll mean is that your 4,000, if you multiply something by 0.03, it's going to become much smaller. And so you haven't actually got the right ratio in there, because what we want this is to grow by 3%. And so it's actually going to be 0.03 plus 1, because it's going to grow. So already that's the $4,000 there. It's going to grow by another 0.03. Okay, so whenever you're doing these sorts of percentage growth questions, if it's money or anything like that, it'll always be something like this, 1.03. Please ask me if you don't understand this, I'll explain that better. 1.03, it's going to grow by itself plus a little bit more, and that's the 3% there. Okay, please see me if you don't understand that. Okay, and how many terms do we want? We want after 10 years, so let's do 10. Okay, let's do it. What was our formula? It was Tn is equal to A R n minus 1. So our 10th term will be A, which is 4,000, times, I was putting brackets, our ratio, which is 1.03 to the power n minus 1 to the 9th power. Okay, and that'll be your answer. And should I do it? Look, I don't really care. Do it on your calculator. 1.03 to the power 9 multiplied by 4,000. Don't care. Figure out what the value is after 10 years. Now, if you think back to compound interest from maybe year 9 or year 10 or whatever, this is actually the formula for compound interest, where you've got the value is equal to your principal time and the 1 plus the interest rate raised to the nth power, whatever. That's actually where the compound interest formula comes from, in case you're interested. And there you go. That's geometric sequences. I'll see you in the geometric series video.